Why does this seemingly cold and desolate planet make everyone feel uneasy? It was once thought to be a dead and silent frozen world, but now it has been discovered to hide ice volcanoes, oceans, and even signs of life. It is so far from the sun, so why is it still so mysterious? What is even more surprising is that Arrokoth near Pluto may be able to uncover the great mystery of the origin of the solar system. Pluto and Arrokoth, these two distant celestial bodies, seem to hide amazing secrets that we never imagined. In the next period of time, let us explore the truth behind these celestial bodies together. July 2015, NASA's New Horizons spacecraft flew past Pluto, completely breaking our previous understanding of Pluto. Pluto is not the icy, dead sphere we imagined, but a world full of complex landscapes and vitality. One of the most shocking discoveries is the huge network of ice volcanoes on Pluto, or perhaps more accurately, they are cryovolcanoes. Unlike any other celestial body in the solar system, the existence of these cryovolcanoes overturned our understanding of this dwarf planet. In March 2022, with more detailed data analysis, scientists discovered that the heart-shaped bright edge of Pluto's southwest quarter actually has a huge dome-shaped mountain range, with a rough texture on the surface. One of them, named Right, Mons, is about 3 miles high and spans 90 miles, and its volume is equivalent to the Mauna Loa volcano in Hawaii on Earth. Nearby, there is another huge dome-shaped mountain named Picard Mons. They are not volcanoes, but If these cryovolcanoes do not erupt lava, but are a mixture of water, ice, methane, and other volatile substances, oozing out slowly like a semi-frozen glacier, Pluto's landscape would be even more shocking. However, what is most surprising about these cryovolcanoes is their youth. They have almost no impact craters around them, which indicates that these cryovolcanoes were formed in the recent geological period. Their age may be only a few 100 million years, or even younger, which is almost a snap of a finger on a cosmic timescale. Some scientists even believe that this area is still active today, slowly reshaping itself, and the semi-frozen magma is oozing from inside Pluto. These discoveries have led to a huge change in our understanding of Pluto. But these activities are also puzzling. It is so small, only 2/3 the size of the moon, and so far from the sun. Logically, its internal heat should have disappeared long ago, but the discovery of New Horizons completely broke this common sense. The existence of these huge cryovolcanoes shows that Pluto still retains enough energy to support its geological activities, and even extend into the late period of its life cycle. This discovery has forced scientists to rethink how dwarf planets work. And what is even more puzzling is what kind of heat source is driving Pluto's interior. Some scientists believe that this heat comes from the radioactive elements in Pluto's rocky core, while others speculate that there may be antifreeze substances inside Pluto, such as ammonia, which can keep water in a liquid state and prevent it from freezing. No matter what the heat source is, Pluto's cryovolcanoes have become clear evidence that this distant planet is not completely dead. When New Horizons flew past Pluto, scientists also discovered huge cracks and depressions. On Pluto's surface, these structural features reveal the dynamic changes inside Pluto. The ice shell of Pluto seems to have been stretched and torn by forces from below. Scientists believe that these cracks may be a sign of a slow freezing of Pluto's subsurface ocean, although it sounds a little incredible. Pluto may really hide a deep liquid water ocean dozens or even hundreds of miles below the frozen surface. You might think, how is this possible? How can Pluto, which is so cold, maintain a liquid state of water? In fact, the key to all this lies in the expansion of water when it freezes. Just like a water bottle bursting in a refrigerator, if Pluto's subsurface ocean is gradually freezing, its expansion will push the surface, causing the ice shell to crack. In fact, the images show that Pluto's ice shell has indeed experienced stretching and cracking during its long period of evolution. However, there is no evidence that this subsurface ocean has ever completely frozen. If it were completely frozen, the water would form a dense ice called ice 2 under high pressure, and this ice body would shrink in volume, leaving traces of compression, such as the shell layer collapsing inward. But New Horizons did not find any of these compression signs. All these discoveries lead us to a bold hypothesis. The liquid water beneath Pluto's surface may still exist. As Dr. Alan Stern, the principal investigator of New Horizons, said, how could there still be liquid water deep in Pluto at a surface temperature of -382 degrees Fahrenheit? Scientists' explanation is that Pluto's core and mantle may still retain the initial heat from its formation, and this heat is maintained by insulating materials. Recent research has even found that there may be a layer of gas hydrates at the bottom of Pluto's ice shell, a mixture of gases such as ice and methane. This layer of gas hydrate acts as a thermal blanket, slowing down the loss of heat and keeping the ocean warm. In addition, the ammonia in Pluto's water also acts as an antifreeze, keeping the water in a liquid state even at extremely low temperatures. All this suggests that Pluto is not a simple cold planet, but a planet with an ocean, even though its ocean is locked by a thick ice shell. This concept puts Pluto on the same level as Europa and Enceladus, which have oceans. The only difference is that Pluto's ocean does not have a giant planet next to it to exert gravity and heat it up. A 2020 study put forward a shocking hypothesis. Pluto may have been formed by a hot method. A strong impact may have rapidly released enough energy, melting the ice inside and directly forming a liquid ocean. If this is true, Pluto's ocean may have existed for more than 4 billion years. This discovery makes us rethink Pluto's dynamism, that it may be more vibrant than we imagined, and may even be able to support life. At the same time, the thin atmosphere above Pluto has also attracted the attention of scientists. This layer of blue haze composed of nitrogen and a small amount of methane is thin and fleeting, which is another shocking discovery of New Horizons. The spacecraft captured the glow of this blue haze when Pluto rose and set. As Pluto approached the Sun, its atmosphere once expanded. When Pluto approached the Sun in 1989, the frozen gases were heated and sublimated, causing the atmospheric pressure to increase. According to observation data from Earth, Pluto's atmospheric pressure increased by about 3 times, from 1988 to 2016, as more nitrogen entered the atmosphere. However, as Pluto gradually moves away from the Sun in its 248-year orbit, this trend is reversing. In 2019, astronomers made a surprising measurement by observing the occultation of a star. Since 2016, Pluto's atmospheric pressure has dropped by more than 20%. Another occultation analysis in 2018 confirmed that the atmosphere is indeed getting thinner. Pluto's nitrogen began to freeze, forming frost and falling to the surface. If this phenomenon continues, Pluto's atmosphere may collapse, and it may become a frozen planet with no air. Pluto's sky will become clear and cloudless, and only near the areas illuminated by the Sun can some signs of steam be occasionally seen. The lucky thing is that this process is not a permanent catastrophe. As Pluto's orbit progresses, hundreds of years later, when its south pole turns towards the Sun, the atmosphere will expand again, and the ice will sublimate again. But before that, we are witnessing a rare astronomical phenomenon: atmospheric compression and a possible temporary collapse. When the atmospheric pressure drops, Pluto's beautiful blue haze will gradually disappear. What is surprising is that Pluto's overall brightness may have increased slightly, because more of the surface is covered by a fresh reflective layer. In 2015, when New Horizons flew past the equatorial region of Pluto, scientists discovered a completely unexpected phenomenon: sand dunes. That's right, they are sand dunes, just like the ones blown by the wind on Earth. They are located at the junction of Pluto's vast ice plain and the edge of the mountains. These dune features were confirmed in a 2018 study led by Dr. Matt Telfer. These dune-like ridges appear in a 46-mile-wide area on the western edge of Sputnik Planitia, which is the large heart-shaped ice plain on Pluto, and the junction of the tall ice mountains named Aladrisi Montes. These dunes form a parallel undulating terrain, and the visual effect is like wind-blown sand dunes. But the sand here is composed of frozen methane grains. So how did the dunes form in such a thin atmosphere? Pluto's surface pressure is only 1 Pascal, which is 100,000th of the Earth's atmospheric pressure. The conventional scientific view is that Pluto's thin atmosphere cannot lift sand grains or move them at all, but Pluto has apparently found a way. On Pluto's sunlit day, the solid nitrogen ice on Sputnik Planitia sublimates directly into gas. During this process, the nitrogen gas releases a large amount of energy. As this gas expands and rises, it temporarily carries fine grains into the air. Dr. Telfer and his team found that if methane ice grains, a few hundred microns in size, are lifted by this sublimation effect, Pluto's weak wind speed, about 22 miles per hour, is enough to transport these grains and gather them into sand dunes. These wind-blown grains are likely to come from the frozen methane in the nearby mountains, and these mountains have methane ice caps. Of course, they may also contain some nitrogen ice fragments, because the surface geology of Sputnik Planitia is relatively young, and the nitrogen glaciers are constantly flowing and renewing. These sand dunes themselves are also likely to be relatively young, perhaps formed in the last 500,000 years. The discovery of Pluto's sand dunes completely changed our view of this distant world. We once thought that a thin atmosphere meant that Pluto was a dead planet, but the facts are just the opposite. A thin atmosphere does not mean that it is. Not active Mars also has a very thin atmosphere, but it has carbon dioxide sand dunes on its surface. Titan, a moon of Saturn, also has sand dunes made of carbon-hydrogen compound grains. And now, Pluto has also joined this ranks, proving that even under low pressure and extremely cold Kuiper belt conditions, planetary winds can still shape the surface of celestial bodies. After New Horizons left Pluto, it continued to move towards the more distant target, Arrokoth. On January 1, 2019, the spacecraft flew past this small celestial body at a distance of about 4.1 billion miles, giving mankind the first opportunity to observe a primordial Kuiper belt celestial body. Up close, New Horizons discovered that Arrokoth is like a cosmic snowman. Two irregular objects are tightly joined together. The main body of the object is about 22 miles long. One side is about 13 miles wide, and the other side is about 9 miles wide. It is a contact binary system formed by the merging of two independent celestial bodies. The images taken during the flyby show a surprisingly smooth surface, a uniform reddish color, and very few craters. From many perspectives, Arrokoth appears to be one of the most primordial and ancient celestial bodies we have ever visited. It is like a chemical time capsule from the dawn of the solar system, preserving countless secrets waiting for us to unravel. But one of the most catching features on Arrokoth's surface is its large, lumpy structure. These structures occupy a larger and major part of the object. The latest high-resolution image analysis shows that the larger part of Arrokoth, which is nicknamed Wenu, is covered with about a dozen lobes, each about 3 miles wide. What is surprising is that these lobes are so similar in shape, size, color, and reflectivity. They are almost identical. The researcher and co-author Dr. William McKinnon pointed out that Arrokoth almost looks like a raspberry made up of small subunits. This object is so well preserved that we can directly see its building blocks. These mosaic-like components indicate that the formation process of Arrokoth was extremely gentle, as if it was accumulated bit by bit. Scientists believe that these lumpy structures are fragments formed locally, originating from the same initial nebula. They were not broken fragments formed by a violent collision, but more like brothers who grew up together and gradually merged into a whole. Based on the shape and chemical composition of Arrokoth, scientists have found a lot of evidence to support this view. The two lobes of Arrokoth met at a contact point, and the poles and the equator are aligned. This indicates that these two objects once orbited each other and gradually approached in a spiral way. The lobes themselves are flat, and the shape is a bit like a pancake, which may be the result of their merging in a rotating debris disk. What is particularly noteworthy is the uniformity of the surface composition and color of Arrokoth. This indicates that its constituent materials may come from the same region of the solar nebula. If Arrokoth was formed by the traditional layered accumulation method, that is, by randomly colliding and collecting materials from different places, then we should see more heterogeneity. However, all signs point to a different formation mechanism, the cloud collapse model. In this model, a dense clump of solid particles in the primordial solar nebula collapsed under its own gravity, directly forming a celestial body, thus skipping the stage of violent collision. Dr. William McKinnon, the co-author of the study, explained that Arrokoth's particles combined tightly at low speeds, orbited each other, and finally merged under the action of complex gravity. This discovery almost rules out the traditional layered accumulation theory and strongly supports the cloud collapse model, revealing a major breakthrough in the formation process of planetary embryos. Planetary embryos are the basis of planet formation. In addition to the strangeness in form, the dark red color of Arrokoth's surface is not simple either. It reveals the chemical story of the early solar system. New Horizons spectral measurements show that Arrokoth's surface is covered with methanol ice and complex organic molecules, possibly thorians. We will explore this in more detail later. What is unexpected is that no water ice was detected on the surface. Water ice is very common on many celestial bodies in the outer solar system, and even tiny comets and Kuiper belt objects will show traces of water. The lack of water ice means that either the water is buried deep under the organic layer, or the conditions during the formation of this planetary embryo resulted in an extremely low water content. In fact, Arrokoth belongs to a class of super objects. Because the surface is rich in organic matter, its spectral reflection appears extremely red. This red substance is believed to be rich in tholins, which are a complex type of macromolecule, usually formed by the interaction of cosmic rays and ultraviolet radiation with simple compounds such as methane, ammonia, and nitrogen. Do not represent life, but they are prebiotic chemical substances containing many chemical building blocks of life. The presence of frozen methanol has become another clue to reveal the history of Arrokoth, but due to Pluto's extremely weak gravity and extremely cold surface, these volatile substances either escaped into space over tens of billions of years, or underwent chemical transformations. And the tholins, which are rich in sulfur, indicate that compounds such as hydrogen sulfide once existed and contributed to the surface chemistry of air. By studying these materials up close, scientists can get a glimpse of the chemical environment of the outer solar system 4.5 billion years ago. These substances may have come to Earth through comets and asteroids, and provided key elements for the birth of life's components. In essence, this lifeless celestial body preserves the organic chemical processes of the early solar system. It is like a frozen chemical time capsule, or perhaps it represents the initial material package of the origin of life. These discoveries can't help but make people think, could life be nurtured in Pluto's oceans? If Pluto can preserve a liquid ocean for tens of billions of years, then it means it has a stable, aquatic environment, which is crucial for all life forms we know. This ocean may contain ammonia and salts, which not only serve as antifreeze agents, but also may act as nutrients. And Pluto's core, if it can provide heat and chemical gradients, may provide an energy source for life, just like the hydrothermal vents at the bottom of the Earth's oceans. Of course, there is currently no evidence that life exists on Pluto. The mission of New Horizons was not equipped with tools to search for signs of life. But even so, the fact that an ocean exists in an environment where stellar energy is scarce still suggests that Pluto may be more suitable for life than scientists previously thought. A researcher once mentioned that if there is life in Pluto's subsurface ocean, then these lives will be shielded from the harsh cosmic radiation and can avoid extreme temperature fluctuations. Such life forms may be microorganisms that obtain energy by relying on chemical reactions in rocks and water. Although this possibility is not high, the question remains undecided. Did microbial life once emerge in this hidden ocean, or is it still possible for it to emerge here today? Perhaps, only when future missions delve into these deep, dark waters will we get the answer. New Horizons gave us a brief glimpse of a few days of Pluto data and a few hours of Arrokoth data. Although the time was short, these observations completely changed our understanding of these distant celestial bodies. Years have passed, and planetary scientists are still deeply studying this data and constantly making new discoveries. Even so, many mysteries remain unsolved, or are just beginning to emerge. For example, did Pluto recently experience cryo eruptions? Is this activity still ongoing? As Pluto's atmosphere gradually thins and is replenished, how does the climate of this dwarf planet change? The existence of a subsurface ocean has led us to ask more questions. Does it touch Pluto's rocky core, or is it sealed under a layer of gas hydrates? How thick is the ice shell? Is there liquid water near the surface? Are all cold classical Kuiper Belt objects like this, or is Arrokoth a unique exception? To answer these questions, scientists urgently need new missions and innovative research methods. Nowadays, the scientific community is becoming more and more interested in returning to Pluto. For example, NASA has already funded preliminary research and plans to implement an orbital probe mission, not just a simple flyby, but a research project that can stay on Pluto and its moons for many years. This mission envisions that the spacecraft will arrive at Pluto, enter orbit, perform higher-resolution mapping, track seasonal changes in Pluto's atmosphere, and may even deploy landers or impactors to analyze the composition of Pluto's surface. Up close, since entering orbit requires significant deceleration, researchers are considering advanced propulsion methods, including highly efficient ion engines, and even future concepts like nuclear propulsion. One ingenious idea is to use Pluto's largest moon Charon as a gravitational brake. Research found that the orbiter can use Charon for several gravitational assists, which can not only effectively decelerate, but also exit Pluto's orbit to a great extent, minimizing fuel consumption. This will give the spacecraft a chance to cruise in the Kuiper Belt and finally fly to other celestial bodies. According to the proposed plan, the spacecraft will stay in Pluto's orbit for 2 years, use Charon's gravity to exit the orbit, and continue to travel to other Kuiper Belt objects, possibly another cold classical celestial body, or even another dwarf planet. If this ambitious plan is realized, it will greatly expand the legacy of New Horizons, turning a brief reconnaissance mission into a long-term expedition. Currently, NASA has extended the mission until the late 2030s, and this lonely probe will once again bring signals from the edge of the world to human ears, and even leave the end of the solar wind to enter true interstellar space. The two names it left behind, Pluto and Arrokoth, may be mentioned again and again by future generations, not because they are the farthest from us, but because they were once the most misunderstood. We thought it was the end of a frozen death, but they proved that the edge of the solar system is far from as silent as we imagined. Perhaps the real surprise is never from within, but from without, and the secrets hidden in the cold shadows are still waiting for us to get close. And all this has just begun.